ไม่ใช่ตอนนี้บ่าย
Am I supposed to start
แต่
now?
ว่าในรายการคุณเลยกำหนดแล้ว
Yeah. Are we on? All right.
เนี่ยโอ้ยไม่มีตังค์ซื้อใหม่
Okay, so this is me. So this is a talk that I gave at an architecture conference, and they wanted me to talk about enterprise architecture. I actually hate enterprise architecture. You'll learn why in a little bit. But yeah, so my name is Ben Sherry. I'm the founder and chief systems architect for Proteus Technologies, and I'm an angel investor for Proteus Agility, who is our sponsor. Check out our booth and our product. I'm going to talk about what we're doing in a little bit. So if it sounds like an advertisement, it's because we spent a lot of money to do it. I'm not going to apologize too much. All right, so we're talking about architecture, right? So people think agile architecture; these things don't go together, right? You might think, you know, you can't be doing architecture. That's a bunch of upfront stuff. That's not agile. Or you might be a company who is focused on, you know, we've got a big architectural investment, so we can't do agile, right? Well, these are myths. These are absolutely false, and we're going to talk about why that is here. So let's, you know, I'm not going to get into too much about what agile is. We had a great keynote for that, and the talk just in front of me. Although I can't understand Thai, I know the people and I know what they're talking about. So I know that you all know what agile is now. So I want to talk a little bit about what architecture is. Architecture is form. This may sound subtle, but it matters. It's more about form than structure, right? This is a great room, actually. This is a really cool facility. It's my first time here. Definitely need to come back. But, you know, the architecture of this room is not the walls and the glass. It's the space that it creates, right? And how we use space, how it can be used, you know, like here right now, we've got a big central area, and from two directions we can do stuff. But you can also split it up and divide it, right? There's a lot of thought going on as to how the room will be used and how people will occupy it. So architectural styles evolve from a lot of trial and error, which sounds rather agile. So Jim Copeland gives an example of a bottling plant, like a Coke bottle plant, as an example. So if you think of the bottle as the structure, the bottle that comes out, you think of the mold that the glass gets injected to is the form, right? The mold itself is the implementation of the architecture. The glass bottle that results is not the architecture, right? You could inject chocolate or some other thing into this form and still have the essence of the architecture come through. So, you know, it's, the space that is created, you know, with these walls, it is the space that's created is the architecture, not the walls that make the space. So, when we're talking about architecture and software development, the intention here is to always focus on value. And we're always talking about measuring return on investment. And this is actually kind of a frustrating thing because big companies who say, we must do architecture, we must do architecture, and management will always insist that the technical team tell them what costs are and what their options are. But they themselves rarely will ever say, this is what the value we're going to get from this business feature is. If you try to pin them down and say, okay, we put in, you know, $2 million here, how much, you know, is our sales going to be over the next couple of years? They'll almost always refuse to do this. But if you're not talking about value, then there's no point in talking about architecture. So for example, let's say that there was a huge chasm, right? A big place between two mountains and you wanted to cross between it. If you didn't care about the cost in terms of time, money, resources, you can just get a bunch of rocks and fill the thing up and then walk over. That is a solution, right? That's a brute force, naive, very expensive solution. But without any reference as to what the value from clearing this chasm is, how do you know that's not a valid solution, right? Or you can say, all right, we're going to build a bridge. We're going to use triangle formations to make it strong, and we're going to apply engineering principles so that, okay, we've got this bridge made out of metal and wood and possibly stone, but it's a lot less effort than just filling the thing up with a bunch of rocks. That is architecture. That is design. That is delivering value to the client. And if you're not focused on that all the time, you're not doing architecture. Likewise, if you're not focused on that all the time, you're not doing Agile. So a good architecture is always talking about focusing on value. Good architecture identifies the stable parts of the system. How many people here are in the software development field? Right? You write code or you have to do design. I mean, you're in computer software development. You all have just chosen to participate in the one industry that has the largest failure rate and the highest overhead of any industry invented in all of humankind next to war. Congratulations. Right? So why is it that we subject ourselves to this? I mean, because depending upon what your definition of success is, we either have somewhere between a 50 to an 80% failure rate. So, like, one definition of success is, a project didn't get canceled, it didn't fail, you actually delivered something, and the client started using it. Industry average right now, 50% of projects don't meet that criteria. That's pretty bad. Well, it gets worse. My definition of success is if at the end of a project when you've delivered it, if the client could go back in time from the beginning when you first proposed the project, and knowing all the surprises that came up, and all the extra costs, and all the extra time, and all the random things that you could not have predicted. If you went back in time knowing all that, he would still say, yes, I want to do this project. I'm going to do it. If the client says yes, that's my definition of success. That's what we try to achieve at Values Technologies. Right? 80% of projects fail by that definition, at least. Some would argue 95% or 99% of projects fail in our industry. So, why do we keep doing this, right? What is a solution to doing this? And I feel very strongly, fundamentally, that architecture is the way to do this. And why is it that we have such a high failure rate in the software development industry? It is because of Moore's Law, right? Every 18 months, things get twice as fast and cost half as much, right? Imagine, cars can go light speed and only cost 5 cents if we did that from the day that the first car was made, right? There's no, when doing building architecture, we'll introduce materials that might have a 5% change off of what's been standard for the last 30 years, and that will be a big deal, right? In software development, every couple of years, we completely revolutionize what technologies are available to us and start over. Some projects, it's actually cheaper to wait 3 years for new technology to be invented than to even start, depending on how far you're pushing the envelope. Right? Our industry just changes too quick. So what we have to do is we have to figure out what are the stable parts of the system. Things that stay consistent throughout the lifespan of the project, which is throughout the lifespan of when the client expects to get value. And separate those things out and clearly identify them so that we can focus on the dynamic aspects of it and address these inevitable changes that occur that is unique to the problem of software development. Architecture lets you identify these stable parts up front, know what are the things that are going to be consistent throughout the project, and set architectural drivers to allow you to make the tough decisions much easier later. So, introducing constraints, which is what I call architectural drivers, right? Which is saying this is the process that we will use to deploy our web services. We're going to be a RESTful-based system versus a SOAP-based system. whatever you choose to do. You're going to be an object-oriented type system. Again, talking about the form of how we're going to do the development, how we're going to build this thing. Making these choices up front, which are hard choices, make the easy decisions, which are the dynamic ones that come and hit us without being able to predict them, much easier. Constraints actually give us freedom, right? So if you're imagining, if you've got a huge pile of rocks that you want to move from one place to the other, there's big rocks, there's medium-sized rocks, there's little tiny rocks, right? What is it that you naturally do to be most effective in moving these rocks? Right? You got a wheelbarrow, you put the big rocks in first, and then you put the next size rocks around it, and then the small rocks will just fit in, right? So once you got the big rocks in, most of your work is done, and the small things will just fit in, and those decisions you can change around no problem. But if you put the small rocks in first, and you focus on trying to predict ahead of time, and you can't differentiate what things are more important than others because you haven't set architectural constraints, then if you filled your wheelbarrow up with small rocks first, you've got no place to put the big rocks. And then you have to undo and dig out the small rocks and start all over, right? This is what we do when we don't understand the value of the impact of the decisions that we make. Right? So you got to identify really quickly what are the big rocks in your project. And if you can do that successfully, the rest of the problems kind of take care of themselves. So, goals of architecture is to reduce the cost of change. We want to reduce coupling and increase cohesion. Coupling is the degree in which program modules are intertwined. Right? You make a change in this one module, does it affect 3 or 4 other modules? That's a tightly coupled system. That's a bad idea. Right? So we spend a lot of energy trying to make our systems loosely coupled. And in web services, I'll often give the example of a RESTful architecture. Is a way to reduce coupling. Cohesion, on the other hand, is a good thing. Now, what is cohesion? Because they sound very similar. Remember that architecture and software development and processes is all about the people. It's all about the humans. Okay? Proteus Agility, our motto is humane software for humans. That is the focus. Right? Complexity. Software development is just the art of managing complexity. Taking the big problems, breaking them down to smaller problems, breaking those down to really small problems, and then trying to put it all together in a manner that you don't lose information, that you still retain the value. That's what all successful processes do. Well, cohesion is the measure of how strongly related or focused a single module in the system is. So that, just like a Scrum team where everybody sits in the same room, everybody all together from the beginning, if in one program module, everything is focused on one small key bit of value, and there's not extraneous things that aren't related to that business goal in this module, then you have a highly cohesive system. And you also know that when 2 or more people are working on that module, that they're going to be impacting each other, and a highly cohesive system will make communication between them easier, right? And that's what good architecture, improve communication between people. That's the goal. So does anybody have a question about coupling and cohesion? Because that's sometimes a subtle point. Right? So coupling bad, cohesion good. Remember that. So this also, loosely coupled systems allow distributed teams to work better together, right? If you have loose coupling of highly cohesive systems, you have small teams working on small systems sitting next to each other. They can be distributed across the whole system because they're loosely coupled. And they know that if I'm just working within the impact of this one region, I don't have to worry about impacting these other parts of the system. And when you hear big enterprising companies talk about their global system, this is global. The impact of this decision is global. If they're not talking about a fundamental architectural thing that's going to set a design concept that applies to everybody, if they're talking about a design of a feature that's going to affect everything, what they just admitted is that they've got a completely tightly coupled system that has no cohesion, and it's crap. They've got no architecture. So whenever you hear people talk about their global enterprise architecture, that is an oxymoron in almost every case. As a project that's doomed to never, ever be delivered. So again, when you have a really highly cohesive system, you've got a shared vision amongst your team in which everybody can proceed. Everybody has a context in which to execute. So, talk about what's going on with enterprise architecture. So it's never the intent, except for maybe with the vendors. But if you attach global to something, it never gets delivered, right? You get bigger budgets, you get lower expectations, you get throw it over the wall design with these people who are called architects that don't talk to the developers, that don't talk to the testers. They probably talk to the business owners or stakeholders, but they purposefully use big words and technical concepts in order to not be pinned down for anything. You've all worked in an enterprise organization, you've seen this. Right? They're beautiful works of fiction. 2 inches thick documentation that took months to do, that no one's going to read, and it tries to predict things in a highly complex system and pretends that you know things that you can't possibly know. All you've done is set yourself up to failure. So, it's not just the customers think they want to see this, but it's not just the architect people also. It's also a lot of developers, getting enthralled with their UML charts, right? UML or whatever notation you want to use is good for documenting something that you already know how it works. It's a known system. It's pretty much already been implemented. It's not a system that's going to be implemented. You do this because you need to document the way it works for people who want to use the system in the future. Almost never useful for putting together something that you haven't yet seen in operation. So, people confuse the rules of drawing with the rules of construction, not realizing that they are not the same. This is actually an observation made in the 1400s, and it applies absolutely today to computer architecture as well. So I like anybody here read Architectural Digest? Seen these beautiful pictures, right? You get pretty pictures of big empty rooms with no people in them. And then what happens when people actually try to use this space, right? Some of these wonderful buildings that everybody went ooh and all about on Architectural Digest, they have to be rebuilt, they don't get used, they never live up to the thing because they were just grandiose plans, high risk, and nobody thought about the people who use it. So you've got to keep things real, you've got to keep them sustainable. Right, so how much architecture do we actually need? What are the approaches that have been taken so far? So classic waterfall is big upfront design. Okay. In the 1980s, case tools, ADW, extension IEF, were all about using entity relationship and data flow diagrams, and they were going to generate code, and programmers were going to be obsolete. Everybody told me this in the 80s. I knew better, but people spent a lot of money on this. And people spent a lot of time doing big upfront design. What they couldn't deal with is emergent requirements. As soon as something happened that they did not predict, that a bunch of guys in a room who weren't even in front of the customer couldn't predict, imagine that, their design was broken, their architecture failed. Right? So emergent requirements is a reality on every single project you will ever do that has any value at all. Because the value comes from the risk. The value comes from doing the new stuff that you weren't able to do before. If you just decided that, all right, our project was implemented in .NET, it does these features, but we want to implement all the features again in Java, you're not talking about delivering any value. You're talking about shifting around the chairs on the Titanic, right? You can do that and probably be very successful, for your definition of success. But that doesn't actually deliver any value to stakeholders. So the XP community, the first Agile community, has the concept of no upfront design. Literally, it says in one of the XP books, spend 15 minutes to half an hour and start writing code. If your system is small enough that the entire design can fit in your head, you can do that. But again, systems that have real value cannot do that. And it's a myth. It's a lie. Because the systems that have been successful doing this, and I was involved with Chrysler was one of the first XP groups, and I was a consultant to one of their projects. And they were doing, true XP, and they didn't have design. Everything was test-driven development and all that kind of stuff. And they're saying, we don't have any architecture. That was a lie. Because they had people who had been working at Chrysler on their systems for 30 years. They had 30 years of domain knowledge built up, right? It's like if your car is, there's a joke about the lady who goes to take her car in because it's not working. And, it's like, I'm going to have to spend thousands of dollars, I'm really scared. And the guy goes in and looks under the hood, changes something out real quick, 15 minutes later, bing, fixed. Right? And she gets the bill, it's $200. And then she's upset. It only took you 15 minutes to do that, And, so I want to know why does this cost so much? It says, here's the bolt, $2. Knowing which bolt to replace, $198. Right? Domain knowledge, if you already know everything about the system, right? That doesn't come for free. It's an investment. If your company is lucky enough to have that, then you're great. But how many of us in our systems have people in our environment who have 10 or more years of domain knowledge in the thing that we're working on? Very few. If you have that, you're lucky. You don't need to do as much upfront design because you have a guide, a mentor, a real architect available to you who can answer all these questions because they've been experiencing it, right? So every project that does no upfront design that has succeeded has had somebody with just enormous amounts of domain knowledge to lead them. So now we talk about the new thinking in the Agile and in the Lean community, so Lean came out of Toyota, the Toyota way, like this. The approach that they take is just enough architecture, right? A rough upfront design, right? We don't need to have a detailed map that tells us exactly, go 40 inches this way and then turn 13 degrees south and then go another 100 meters this way. We don't need that. We just need to know what the landmarks are, right? We need to point out what the big issues are that are going to be the big values or the big risks. Those are often the same. And see those landmarks and then go towards them, right? So you can, you just have a rough sketch of the map and you can explore options, but your results of your design can't be a document, can't be a big UML thing. It's got to be executable code, right? You put in your shims, like if you're going to do a RESTful architecture, there's going to be some stubbed out services that you can actually make HTTP requests to. And even if they get back fixed results, at least everybody who's dependent upon those external APIs knows how the system is going to behave. So you can be loosely coupled and the individual teams that are highly cohesive can go focus on their details and feel very confident that their decisions, as long as they comply with the APIs of the other systems, are not going to break other parts of the system. And you know that when I'm in this little loosely coupled team and I've done something that says, I need to change the way we expose ourselves publicly, then you know that that's a big decision. That's a big issue, because you're going to break people in other systems. And this happens. But it's also a red flag that means, okay, now we need to have a meeting. Right? Whereas normally, your team can just work amongst themselves and be producing code. And of course you're using test-driven development. And of course you're using continuous integration, so you know your stuff keeps working. It's not going to break. And you can get velocity and you can move fast. And you don't have to slow down. Whereas enterprise companies have like a weekly meeting that lasts 4 hours, and everybody has to be in the team. And it's just a giant time sink. I can't tell you the number of times that I've done client projects for big companies. Like, the joke at IBM was that IBM means I've been in meetings. And as a developer in there, for my first IBM project, I spent 80% of my time in meetings, and only 20% of my time writing code. And that's very common for a lot of big organizations. So, talk about Agile Values and architecture. All right? Programs must be written for people to read and only incidentally for machines to execute. If you ever read the book Structured Interpretation of Computer Programs, which is learning about lists for speaking. What is the correct definition of Agile? And so that's quoting Hal there. I'll quote me. Humane software for humans is what everybody should be reaching out to try to accomplish. And that's really, I think, if this is a fundamental goal of your organization, of your development group, it will show. And people will appreciate it. Your customers will appreciate it, your developers will appreciate it, your staff will appreciate it. All right? Agile is an adjective, it's not a noun or a verb, it's not the thing. To be agile, you have to be strong, you have the facility of quick motion. You are ready. Having an agile architecture means you're ready to proceed, right? You've documented the big, rough things, and now you can go forward and know that working within your cohesive team, you're delivering value to the whole of the system, even though you don't have to look at the whole of the system all the time. So how do we achieve readiness? Right? Architecture. Architecture makes you ready. So I won't go into the Agile Manifesto. We all know what that is. So, have you all seen the Mayo-Smith Pyramid? Anybody not seen this? Anybody not seen it? Cool. So, the whole idea here is that we need to, grandiose designs incur grandiose risks. Right? So there's a pharaoh. He wants to build the largest pyramid ever, and he builds the first layer. You see the first layer there, and it's going to be grand. It's going to be huge. It's going to be fantastic. He's very happy with the progress. The architect proceeds for the second level. When you see the second level there, and he dies. So this is the pyramid that he ends up with. This is what the guy gets buried in, right? Things happen that we can't predict, right? So what you have to do is you have to focus on immediate practical functionality, right? You're always delivering something of value. Even if it's incomplete, there is some increment of value delivered that reduces risks. So the Pharaoh's son did it this way, right? So he started with a little pyramid. He bought the farm tomorrow, he's got something to get buried in. And then, okay, that was good. And then he add a little shim on this side, and then add a little bit on this side. And finally, he's got a big pyramid, and it's ready to go when he's ready to go, so to speak. So, this is really, this right here is what I'm always thinking about when I'm trying to figure out what the next release of my project is. What is the little shim that's useful, that's building on top of what we are, building on top of our success? Right? The first one wasn't building on top of any success. It was building on top of a concept, a promise of something in the future that we were predicting might be. And then when that future did not manifest itself, all the value escaped. We delivered nothing. Right? But proceeding with small increments of value, right? That's what architecture helps us focus on and identify. Right? So most projects try to say, here's how much it's going to cost. Well, like they say, this is all the functionality we're going to deliver. And the question that they ask is, how much is it going to cost and when is it going to be done? And we always lie to ourselves and try to predict what that is. And unless it's something that you've done 2 or 3 times before, or you've got somebody who's got domain knowledge of 30 plus years, you're going to be wrong about when and how much. So the Agile approach is to reverse this. We want to fix, because risk, return on investment, is all about when it's going to get done and how much it's going to cost, right? That is the value, or that is the investment side of the ROI procedure. Your return is something that the business people have to figure out for us. But they say, based off of this cost, it makes sense for us to proceed. So you need to fix your costs. You need to fix your time. How do you do that? Using Scrum. You do fixed length iterations, right? So if you fixed your time and money, something has to be flexible. And what is flexible is the features that you actually deliver. So we say, we can't predict what is every feature we're going to deliver to, but we can deliver things to you in the order of what's most important or highest risk first. And then we discover what are the next features and what features make sense and what features deliver value. Since this team always costs this amount of money every iteration, we know what our costs are going to be 6 months forward, because the costs are fixed, the time is fixed. What we don't know is how much stuff's going to get done. Right? But we do checkpoints as we go, and as long as the client feels that the progress is good and the value he's receiving is good, it actually gives him a lot more control than what he would have had otherwise. So, how do we do this? Right? So Agile is a reaction against methodological excess, right? Like I was saying before, processes are just ways of facilitating communication between people, facilitating communication between a team. An architecture is a result or a set of guidelines for how you execute your process and what are the value you're attempting to deliver in your process. So all process is overhead. Every bit of energy and effort you spend on process is waste. By its very definition, because it does not deliver any value in of itself. Right? It is dealing with the issue that when you have 2 or more people, the more people you have, the more communication paths there are. That everybody needs to be aligned and proceeding the same way and to communicate between each other to understand and deliver this value. So when you have a waterfall process and you try to predict everything in advance, and you try to estimate everything up front and break things down into stages of design, development, testing, you've just introduced a lot of overhead, right? There's a lot of cost for the process, and your value starts diminishing. Agile is really just a reaction against that, saying we want to do as little process as possible and focus on the value. But we don't eliminate process, just like we don't eliminate architecture. So sometimes reactions can go too far, however, right? So don't abandon planning when you abandon over-detailed plans, right? They say that in the military, new officers talk about strategy. Old, experienced officers talk about logistics. It's all about getting the supplies to the right people at the right time. That's what wins wars, and that's what Eisenhower did in World War II. He was a logistics guy. He was not a real strategic guy or tactical guy. So he always said plans are useless, but planning is everything, right? The act of actually participating and talking and working together on plans and dealing with what your options are if these certain things arrive prepares you to move forward and get you ready to go. But as soon as your plan meets the enemy, the plan itself gets abandoned, right? But while planning, people set, these are what our goals are. These are the things that are fundamentally important, right? The plan is the solution. This is a solution on how to proceed. It's not the goal of itself. Right? How do you go? Put a stick in the ground. Say, this is where we're going to start. There's no necessarily wrong answer here. As long as something is a high value or high risk proposition and you're going to demonstrate some useful bit of it early on, that's a good starting point, right? Just start there. You want to leverage your local domain knowledge, right? You got people who, I get sometimes frustrated on the pure agile people, especially on the XP side. It's like, no, we don't want to make any decisions up front at all. Well, man, if you've been doing this for 10 years, if you've got the domain knowledge of the business that you're trying to do, you've done it for 10 years, you know some things. Put those things down and start with the things that you know are inevitably going to be a part of the system, and then build around that, and you will discover the other stuff as you go. But make some initial decisions. Find the stable parts of the system. We're going to talk about the system is composed of two, how would you say, not divergent, complementary aspects. There is what the system is, right? Which is the data, the components that it's composed of, right? You can't have an airline reservation system without tracking a ticket, without knowing who a customer is, without having flight plans. Those are components of the system that will always be necessary to have an airline reservation system, right? Having one that gives you the best route and how the users interact with it, what is the perceived value that a stakeholder gets, that's what the system does. That's the dynamic part, right? That's the part where you start differentiating yourself from other airline reservation systems. But what the system is very stable. So you want your architecture to define what the system is very quickly. Right? Your design lives in code. It really does. And especially if you use test-driven development where you have automated tests that demonstrate how the code is used and how the code works with good fixture test data that demonstrates real use cases that people will encounter in real life in your domain, you've got the best design document there ever was. It's something that can actually be executed and is executed continuously because you're doing continuous integration. Right? Programmers hate writing documentation. And good technical document writers are insanely difficult to find, actually. It's a pretty powerful career path if you're good at it. And once you get known, I mean, every technical writer I know has more business they can ever handle. It's just you got to deal with people who have no idea what they want, no idea what they're doing, and insist that you make it very clear in your writing. But it's good money. So, you need some documentation. How do you get it? First of all, don't call it documentation. Programmers are really afraid to have to write documentation. Just say to your best dev, the one who has the best domain knowledge of your system, write me an email that tells me how this component works, right? Set a context or a question. Say, send me an email and describe it to me, okay? Because I want to learn how this works. You get that email, cut and paste it, stick it in the wiki. That's good documentation. That's practical documentation. That's what the programmers really think, right? That's about all the written documentation that you need outside of executable code. Get past this. Okay, so you need to do Scrum, you need to do test-driven development, do it. Alright, so there's no software architects in Asia because there's no technical career paths in Asia. Right. If you haven't been exposed to 5 or more technologies and used it real seriously, and you haven't been doing this for 10 or 15 years, you can't be an architect, right? In Asia, you get these brilliant people that graduate from the top school, and the top 2% of their class. They go to the best company. They learn whatever is the technology that company uses, which is either .NET or Java. And they will be brilliant at programming within the technology that company does. And they'll do that for 2 or 3 years. They'll be so good that they'll get promoted to manager. They'll manage 20 other people. They'll never write another line of code again. This is the brain drain that Asia suffers. It's the reason why there's not a single software development company that you can point to that is doing anything innovative like the Microsofts, the Oracles, the SAPs of the world. Because there's no technical experience. Right? My company is actually an experiment to do that very thing. We're 5 years in the running. And I've got a few people now who have the makings of being designers, someday being architects. Right? 1 to 3 people. That's it. Right? So what do you do when you don't have architects? You got to think like an architect. Right? Focusing on value streams. Agile and agile processes helps you do this without having to have that architecture there. Right? Everybody has to think together. You got to get everybody's input at once, because that's really what the person who's got the 15 years of experience, what they're delivering. They've been in all the fights and have heard the stuff from all the different people and have seen it done several different ways. Well, you don't have that one person. You just need to have the people in the room who know how to do it different ways. Have an agreement as to what the value is that you're trying to deliver. And get everybody's input, right? And how do you do that? Well, planning poker discussions in Scrum design meetings are a great way of accomplishing the same thing without having a person who is specifically an architect. This is the way we do this in an agile manner. Send out scouting parties. Try things, right? When you don't have the big expensive architect, you're not sure which way to go. You got like 2 or 3 options that all sound good. You're not sure which is the right one. Do them all, right? Make little assertions, little goals that everyone agrees that we're trying to achieve, and give a little bit of budget, and let them all try. And you will probably learn something from each one of those efforts and come up with a solution that's sort of a combination of the best of all 2 or 3, right? The reality is, in any software system, is you're going to do it more than once anyway. You're going to write the system more than once if you did it the old way. So just plan on doing it, but in small, useful increments instead of throwing everything out. Hire a guide. Get a consultant. This is the proper use of consultants, and this is something that I see that companies have problems with, is that they hire consultants to just augment their labor force, and they just treat them like another person, right? And I experienced this several times for companies where I got called in to do a specific piece of the project, and then I did that piece, and they would just have me continue working with them, but to do other things that needed to get done, because Ben, you're really useful. We like having you here. Just try some of this. But as that happened, they inevitably just started treating me like another employee or whatever, and weren't really leveraging me much. And my solution to that, whenever I felt that people weren't appreciating my input as a consultant, was I raised my rates. And it's funny, 1 or 2 things happen. I say, oh, wow, that's kind of expensive. Sorry, your contract's done. Okay, cool. You can always get forward. Or, suddenly they start paying attention to my input. I've had, one day I had a meeting, the next week I had increased my rates by 50% on a new contract, and the next week everybody was listening to my opinions. They weren't listening to me before. Because people don't know how to use consultants, right? If you could find somebody who has actually delivered systems, has the domain knowledge that you don't have, you can buy them and bring them in-house. You want to use that person, you want to internalize that knowledge. How do you internalize that knowledge? You do it by having them participate in your architecture. Help them identify what are the stable parts of the system. Separate those out from the parts that are dynamic, right? Separate what the system is from what the system does bit. You get them to do that and build executable code around that. That knowledge is now part of your company's knowledge base. Now everybody who's participated with that architect knows this stuff. Okay? You don't have to keep him on throughout the whole lifespan of the project. You can maybe periodically catch up with him, right? You have an initial investment, works with the team. Don't just have him talk to the stakeholders and not work with the team. Make him a core part of the team. But then get stuff done. Have clearly defined values and goals that you want to get from using this consultant. And then once you accomplish that, he's gone, okay? And you won't hurt the consultant's feelings. That's his job. You know, I did this for years in America. My career I was the guy who parachuted in when a project was failing and everyone was about to get fired. And it was for big enterprise companies. And they were hiring me to fix their product, to deliver their product. Okay? What I did inevitably, anyone want to be a consultant? Highly paid consultant. You get $300 an hour if you do this long enough. Here's what you do. You go into a big company, and you figure out who is the smart guy in the room. And you go ask him what to do. Right? It's usually some lower guy who's been around for a long time. He's got the domain knowledge. Okay? He doesn't know politically how to maneuver in his company. So you figure out what he wants to do or what he thinks is the right thing to do. And then you listen to your stakeholders about what their pain points are and understand what their boundaries are, how they work. And then you put together a plan that takes what their guy knows and how their management can work. And you win. It's a cookie cutter approach that I've done many times and say, my first project with IBM was a $40 million project that failed 3 times. And we delivered it. I didn't know a damn thing about that project except for what those people at IBM told me. But what I really spent my time doing was building teams, introducing the process, right? Introducing the techniques so that they could work together, right? I was making them a more cohesive unit. 90% of my time was building the development group, not working on the technology of the system. Right? And the good thing for the client is that when my contract was done, and I ride off into the sunset, they have a team left behind that can continue them forward, and they're in control of their own destiny. That is the highest value that a consultant can deliver to you. That's what we try to do with our customers. Our customer focus is startup companies who don't have the technical team to deliver their first product. So we hopefully like to bring their people in. They work alongside us. We train them as they're building their product. We ship their first product. We're done. They can now take over, and they've got all the infrastructure, all the techniques, and all the goodness from all the experience that we've built up for years. They can get in a few months. Right? That's the goal. That's the way we try to operate. So that's how you use consultants. Boy. Am I out of time? 5 minutes? All right, here we go. So, let's see. Okay, 21st century architectural challenge. Okay, object-oriented development was all the rage, all the big thing, came out in the late 80s. Really good stuff, except for we're not doing it right. Okay, one of the problems that I continuously ran into was when an object is successful, it starts growing. Its interface gets really, really fat because everybody wants to call it and do stuff with it. And people who do SOAP systems, SOA systems, are seeing this happen all the time. Right? The whole idea is you're supposed to break your system into independent components that can horizontally scale, except inevitably one component is the one that everybody needs to touch. And they always want to make a feature change to it. When you make a feature change to that, it changes everybody else. Everything's brittle, right? It's tightly coupled, even though it's supposed to be a distributed system. Well, that's because we're doing objects wrong. We're doing objects as classes within objects. So there is a new architectural paradigm called DCI, Domain, Context, Interaction. And the D, the domain, is really talking about the data. It's the stable part of the system. And objects really should not be so, or classes shouldn't be so smart, right? Your interface shouldn't be so heavy in a general manner, right? So you're saying a airplane, a customer data for an airline reservation system. Depending upon which part of the system it is, you want to do different things with that customer. Now, if customer is an object, or is a class, everybody who needs to do something with that class might expand the size of the API. However, if you're only working, if you just say, here's the bare customer data, and the class only knows how to keep the customer data intact and correct, and ACID compliant. But then, when you're in the context of a part of the system, say, this is the role that the customer is playing, right? Just like actors play roles, right? I could be Laurence Olivier as a person, but in different movies I'm doing different things. I'm being different people, right? You think of the context, the one system, right? The loosely coupled but highly cohesive system is going to use a customer this way. Well, the perspective, the script that the customer plays in that system is not the script that he's going to play in another system. So why do you need to have the interface altered for a global domain object when it only applies to this one context? So in DCI, the approach is to combine data and roles together dynamically. They actually inject new methods into the classes at runtime while the customer is in this context of this one system.